If you could save $23,000 in your annual energy spend, pay for it in about 2 weeks, and install it in about 10 minutes, would you do it? Did you also know that worn equipment and poorly tensioned belt drives can cost you thousands of dollars a year? Hi, I'm Sean Carnes with Browning, and we're here in New York City today. We've been spending some time talking to building managers and chief engineers about their energy spend as it relates to fans and blowers. Don Sullivan's here with me, and he's going to give you some perspective on how much you can save in your building.
Thank you, Sean. The application behind me is a 60 horsepower centrifugal fan. But in a commercial office building like the one we're in today, motor horsepowers can range anywhere from a half horsepower to over 200 horsepower. We're going to explore the different types of applications in these types of buildings and talk to you about potential energy savings. We can categorize belt-driven fan applications into 4 categories. The first is cooling towers. Cooling towers are widely used in every metropolitan city. They're often found in hospitals, universities, and office buildings. Typical drive size can range anywhere from 25 to 75 horsepower, and many are horizontally mounted. Package units are used as part of the HVAC system. They are self-contained with all the components used to pull air from the occupied space, filter, cool, and then blow it back into the area. These motors can range from 5 to 30 horsepower depending on the size and demand of the units. Up and down blast exhaust fans are commonly found in commercial cooking applications. They are used to pull hot air, smoke, and grease through a hood away from the cooking area and out of the building. They're typically 1 horsepower or less. Blowers are the most frequently encountered fan systems, and they're used to push or pull air through the HVAC system. The supply blowers are used to pull the air from the occupied space to the system, where the air can be filtered and a thermal exchange can take place. Once complete, the air is then sent back to the building for occupant comfort. They can range from 15 to over 100 horsepower. The U.S. Department of Energy publishes that notched V-belts, often called cog V-belts, are more energy efficient than standard wrapped V-belts. They also publish that they run cooler, they last longer, and they have an efficiency that is about 2% higher than that of a standard wrapped V-belt. Independent tests have shown an efficiency gain of about 3%. Energy responsibility with belt-driven fan applications can be managed in 4 easy steps. The first is to upgrade from a wrap to a notch-style V-belt and improve your efficiency about 3%. They utilize the same pulleys or shivs that the standard wrap V-belts do, and it's a drop-in replacement. The second step is to inspect shivs for wear. Worn shivs allow belt slip. Wear greater than 1/32 of an inch can decrease efficiency 5% or more. Step 3 is properly tensioning belts. The U.S. Department of Energy states that efficiency can deteriorate by as much as 5% over time if slippage occurs because the belt is not periodically retensioned. The fourth step is the installation of a self-adjusting motor base. Our Browning Tenzo set base provides constant spring tension, and they automatically compensate for belt wear, which reduces the frequency of belt adjustments. They're offered in both a standard and a quick release version. Let's review our 4 steps to energy responsibility. Upgrade from a wrap to a notched V-belt. Inspect for worn shivs. Properly tension your drives. Finally, install a Browning Tenzo set self-adjusting motor base to sustain your tension over time.
Well, that's it. Browning understands how important your energy savings is to you. We hope that you've seen the potential for dramatic savings using the 4 easy steps that Don outlined. Contact your local authorized Browning supplier today. We're looking forward to seeing you and talking with you about your energy savings.